Hello, everyone. I'm Rachel Pohl, and I lead social impact for Unity. I'm honored to be here today to introduce World Ocean Explorer. World Ocean Explorer was one of the 2025 Unity for Humanity winners. For those unfamiliar with the program, Unity for Humanity is a program that we created nearly a decade ago, and it's all about supporting creators using real-time 3D technology to tackle social issues and inspire positive change. The program offers an open request for proposals. Creators submit their projects, and Unity evaluates them using the 14 UN Sustainable Development Goals and a rubric that's centered on vision, impact, inclusion, and viability. And these projects are judged by Unity employees. And then we provide these projects with grant funding, marketing, and technical support. We will be opening this up again this year, so be on the lookout, mid-December. And last year, we had a record number of applications, over 500. And World Ocean Explorer Virtual Immersion was one of the 10 winners and 3 honorable mentions, spanning 9 countries. World Ocean Explorer was created with a simple but powerful mission to bring the ocean to students everywhere, regardless of where they live, through free, immersive, accessible, experiential learning. This winning WebGL is a powerful example of how immersive technology can democratize access to science education. And I love how it brings ocean literacy to life for students around the world, especially in underserved communities. The project was endorsed by the UN Decade of Ocean Science, and it supports the UN Sustainable Development Goal 14, Life Below Water. It's also browser-based and widely accessible, particularly for schools with low connectivity. I'm so happy to have them here today. Welcome, Trisha and Bjorn.
Thank you, Rachel.
Don't forget this. Thanks.
Oh, thanks. Hi, everyone. Thank you. Thank you, Rachel, and thank you, Unity Technologies, for the opportunities presented this year via recognition through the Unity for Humanity Social Impact Prize. Bjorn and I are pleased to be here and to introduce our web-based learning tool for the classroom. We'll get started today taking you through how the World Ocean Explorer project began, how we built it using Unity WebGL, how it's being used today worldwide, and our hopes and goals for the future. My name is Trisha Badger. I'm the director of World Ocean Observatory. I have had the pleasure of working with my colleague Bjorn Grigholm for the last few years as we've developed this World Ocean Explorer platform. Our mission at World Ocean Observatory, or W2O as we're also known, is to advance ocean literacy. We're helping students and people of all ages to understand the ocean's essential role in our lives, our relationship to the ocean, whether we live near it or not, and the myriad ways that we can inspire stewardship through knowledge and understanding. Explorer allows us to share and explain ocean science with students and educators everywhere via an accessible, immersive, engaging, fun, and most importantly, free web-based platform. With me today is my colleague Bjorn Grigholm. Bjorn is the owner and creative director of Visual Solutions Lab, which is a boutique multimedia educational design studio. Bjorn is an external associate at the University of Maine Climate Change Institute and the content and platform developer and creative consultant with World Ocean Observatory. As a Unity developer and designer with a PhD in Earth and Climate Sciences, Bjorn brings a scientist's understanding of data and a developer's creativity to the World Ocean Explorer platform, transforming complex research and concepts into immersive, interactive experiences that make ocean science accessible, engaging for learners of all ages worldwide, and fun. Together, we've built a platform that blends science, technology, and interactive exploration to transform how the next generation experiences and learns about the ocean. So today, we're going to begin by outlining what ocean literacy is, why it matters, and the challenges that teachers face bringing it to classrooms in meaningful and engaging ways. We'll then share how World Ocean Explorer came to be, from vision to launch, and we'll explore the Unity tools and performance choices that make it run smoothly in a browser. And finally, we'll outline how Explorer is being used in classrooms around the world today, what teachers and students are saying about the platform, where the project is now, and where it's headed next. Our hope with our time here today is to share how immersive technology can connect education and exploration in ways that weren't possible just a few years ago. So before we ever opened Unity or wrote a single line of code, we needed to understand why ocean literacy is so critical and why it remains so difficult to teach. So in this next section, we'll be talking about the challenges that World Ocean Explorer set out to address. So the ocean is Earth's life support system. It drives climate and weather. It produces half of the planet's oxygen. It provides sustenance and resources for billions of people. The ocean drives commerce and sustains entire economies. Yet for many students, the ocean exists as a distant and apart concept. Ocean literacy is the understanding of the ocean's influence on us and our influence on the ocean. It demonstrates the ways that our lives depend on the sea and how our choices affect it in return. When students begin to grasp that relationship, awareness becomes responsibility and knowledge turns into action. So the numbers tell us why a new approach is needed. Only about 10% of the world's population ever visits an aquarium or a zoo. Half the population of young people worldwide have little to no understanding of what the ocean is and how it affects their lives. And over the past decade, global awareness of ocean issues has stalled, despite best efforts to raise awareness and increase understanding. Why is this? Traditional educational means and methods are not reaching enough people. To change that, we have to meet students where they are. And they're on screens, and they're in interactive, immersive spaces. Explorer gives students a free, gamified space where the ocean becomes a place they can explore firsthand. So when we started designing World Ocean Explorer, we asked ourselves a series of questions. What lies beyond the traditional aquarium? How can we bring that same sense of wonder and discovery into the classroom? How do we spark curiosity of simply delivering facts and data? What if students can learn through play, by testing ideas, seeing results in real time? These questions and others have served as a guide for the decisions that followed and ultimately have defined what World Ocean Explorer would become.
I can take this.
Yeah, Bjorn.
Now that we understand why ocean literacy matters, let's look at why it's so difficult to teach. The next section explores the obstacles educators face and how technology can help overcome them. Most students learn about the ocean through textbooks, worksheets, and short videos. These resources deliver information but don't necessarily invite exploration. Complex systems, like how temperature and chemistry shape deep sea ecosystems, remain abstract and difficult to visualize at scale. Even teachers who want to dig deeper often lack the tools, time, or resources to make those connections visible. We realized that interactivity could change everything. By placing students inside the science, letting them navigate, observe, and experiment, we could turn learning into discovery and curiosity into understanding. The good news is that classrooms are ready for this shift. In much of the world, schools now have one-to-one devices, reliable Wi-Fi, and teachers comfortable with digital tools. Around the world, access to classroom technology is expanding rapidly as more schools adopt digital learning models. Many students around the world already live in interactive spaces, building, playing, collaborating online, and that number continues to grow each year. The barrier isn't interest, it's access. Even when teachers and students are eager to explore, budgets limit licenses, and many tools rely on costly subscriptions, making it difficult to guarantee the same resources from year to year. Technical barriers add another layer. Installing software can be a bureaucratic maze, and training often overwhelms already busy teachers. That's why we built World Ocean Explorer in Unity for WebGL. It removes those obstacles by running entirely in a browser. No setup, no installations, no subscriptions. Teachers share a link, students click, and the exploration begins.
From challenges to solutions, we'll next tell the story of how World Ocean Explorer was conceived, how partnerships have formed, and what has driven the design from vision to launch. World Ocean Explorer began as a concept at W2O, paired with the skills and vision of Bjorn at Visual Solutions Lab. We set out to merge scientific accuracy with immersive design, to create a gamified space where students in classrooms could visit and learn about ocean virtually via the web. Our goal was to create an interactive aquarium without walls, a space where educators and students could explore real data, learn about real marine species, often rarely seen, some newly discovered, and to explore the relationships between Earth systems and how they connect. We chose Unity because it gave us the creative freedom to combine science and interactivity into a seamless platform that would be easily accessible and, most importantly, free for students and educators to use. Since the beginning, collaboration was essential. W2O is a nonprofit organization. We're located in Maine, in the northeastern corner of the United States. Our funding is quite limited, and our other programs and educational offerings are dependent upon the support of individuals, foundations, private funders. Explorer's founding collaborator was the Schmidt Ocean Institute, whose research vessel Falkor, and now Falkor 2, and their remote-operated vehicle, or ROV, Sebastian, has provided the real-world footage and data that has become the background of World Ocean Explorer's first module, Deep Sea, and a next module that we'll be working on called Science at Sea. We've since grown to include the Climate Change Institute at the University of Maine, the marine science publisher Marabus out of Hamburg, Germany, the Fram Museum in Norway, the South Street Seaport Museum in New York City, and UNESCO's Ocean Decade for Sustainable Development Initiative, as well, of course, as Unity's Social Impact Prize. Each has contributed to, strengthened, and legitimized the Explorer project, providing essential funding, science data, and creative support. As the technical driver behind Explorer, Bjorn has taken these opportunities and transformed data and stories into a living, explorable space. He's going to walk you through that now, how he designed the experience and how Unity made it all possible.
Thanks. So now let's step inside the build. In this section, I'll show you how we turn the science and data into a world students can actually explore. A digital environment where every interaction reinforces understanding. By combining real scientific data with authentic design that captures the look, sound, and movement of the real ocean, we make the ocean both accessible and immersive for students. The experiences invite them to explore, investigate, and interact with science accuracy, and for educators, it becomes a tool to spark curiosity, connection, and ultimately stewardship. I'm about to show you what World Ocean Explorer looks like in action. This is part of our sizzle reel, but everything you're seeing here runs entirely in a browser, powered by Unity and delivered through WebGL. These themes come from our premier module, Deep Sea. Students begin inside a virtual aquarium at the bottom of the ocean, where they can freely explore or take a guided tour. Along the way, they interact with digital exhibits that highlight Schmidt Ocean Institute's research and discoveries. These displays include interactive models utilizing textures from Schmidt expedition footage and imagery, as well as highlighting their research technology. This is Sebastian. Can you scroll down? Up again. HEO video footage of Schmidt's dive expeditions, and an evolving interactive globe presenting geospatial data sets. Outside the aquarium, students can enter 3 distinct deep sea habitats. This one is a whale fall. Each environment, students can explore, interact, and identify species, finding and checking them off the species list like a scavenger hunt that encourages exploration while learning about the ecosystem around them. Here's the deep sea coral environment in Australia discoveries. And finally, we have our hydrothermal vent environment. In addition to interactive displays, we've begun adding learning assessment stations like this one on hydrothermal vents. Here, information is first presented through short videos, interactive slide decks, and then finally, through quick activities, for example, a drag and drop exercise that reinforces what students have just learned. We chose WebGL because it removes friction and transforms accessibility. Schools often face technical, financial, and bureaucratic barriers with additional installations. A standalone app would require installation on every device, IT permissions perhaps, license keys, and frequent updates. It also excludes Chromebooks entirely, which are a backbone in many classroom programs. WebGL bypasses all of that. It runs directly in the browser, no installs, no accounts, no licenses, and no maintenance on their end at least. Teachers simply share a single link, and within seconds, students are exploring on Chromebooks, PCs, or Macs, anywhere with an internet connection. That design decision grounded World Ocean Explorer in accessibility, making it adaptable to real classroom conditions. To make all this possible, we had to be disciplined about optimization. We approached every asset with efficiency in mind. First, smaller builds and faster loading. We used Unity's addressable system to load and manage assets on demand so environments load incrementally instead of at all at once. Combined with strong compression settings, this keeps our WebGL builds lightweight. Next, we compressed textures and meshes and used URP's WebGL settings to balance visual quality and performance. For which media, we use video streaming. The Unity video player and addressable lets us stream HD content on demand, maintaining the immersive experience without bloating the build size. Our interface is built with Unity UI Toolkit and TextMesh Pro. It's adaptable and responsive, scaling smoothly across screen sizes. In our next build, we're utilizing Unity's localization system to support multilingual text and responsive layouts. Finally, web-ready deployment. We host a project on AWS S3 for fast, stable global delivery. After the first visit, the browser caches most of the build locally, so subsequent sessions load quickly and run smoothly, even on modest school networks.
So now that Bjorn has shown you how we built World Ocean Explorer, let's talk about how it's being used. This next section focuses on teachers and students, how we're delivering the platform into classrooms, and what happens once it's there. Our first challenge was to engage teachers. So we brought an educator advisor on board. Her name's Nell Herman. She has 25 years of classroom experience. She's a marine science teacher located in Maine. And we brought her onto our team. She's been instrumental in forming educator advisory groups around the globe. She's helping us through these educators to test early prototypes, refine the interface, and to make sure Explorer is working in real classrooms, not just in theory. Teachers have been and remain instrumental. They tell us exactly what their challenges are, what they need from the resources, such as Explorer, intuitive navigation, language support, content flexibility, and ease of access. Feedback has led to multilingual content, simplified menus, clear learning cues that help teachers guide discussion while letting students explore independently. Teacher cohorts remain key to Explorer's development, an engaged network of educators from around the world collaborating to improve and share immersive ocean education. We now have participants across 14 countries, from around the US to Mauritius, from Costa Rica to Jamaica, New Zealand to Thailand, from Bahamas to Africa. Every new cohort and engaged classroom shares ideas, new lesson plans, and student reactions through an online portal. Some classes are using Explorer as a full unit, Others are using it as a tool to spark innovation for art projects, writing exercises, and climate discussions. Seeing classrooms separated by the sea, connecting through the use of Explorer, has been the most rewarding outcome we could have imagined. To date, 30 educators, 45 classrooms, and more than 1,000 students have used World Ocean Explorer as part of their learning about ocean systems, basic biology, and human health.
Here are a few examples what World Ocean Explorer looks like in the classroom around the world. Teachers are using World Ocean Explorer in adaptable ways in their classroom, sometimes through collective learning, where the teacher projects and the whole class explores together, narrating discoveries and discussing what they find. Other times, it's teacher-guided, where the teacher sets a focus or a challenge guiding students as they connect what they observe to lessons about ecosystems and biodiversity. And sometimes it's self-directed, where students explore individually. It's flexible by design, an experience that scales with a teacher's imagination and student curiosity. One of my favorite parts of the project is seeing how teachers and students take World Ocean Explorer beyond the screen and back into the real world. These are just a few examples. They've sketched species of the habitats they've seen there, built sculptures of the whale fall, and created posters and reports by what they explored digitally, a full cycle of learning that moves from real life to virtual and back again.
Great. So now that we've shared what Explorer looks like in the classroom, let's talk about the impact, what teachers and students are saying, and how the project is being recognized globally. One of the first teachers to integrate Explorer into the classroom was a science teacher named Timothy Dwyer. He's from a high school in Washington State in the Pacific Northwest of the US. Tim shared with us that his students are so captivated that they've continued using Explorer after school. They're using it to simulate deep sea sampling, data collection, and as a tool to practice for the National Science Bowl competitions. Wendy Pilars, another educator from North Carolina, also in the US, said the deep sea module has sparked discussions about ecosystems that her students have never imagined. She said it is the most engaged she's seen her students all year. We're learning anecdotally that Explorer is opening to places that they can't otherwise take their students. This new learning is leading to surprising results: empathy, curiosity, and a new respect for the ocean and for the planet. We're also hearing directly from students. You'll hear here from classrooms in Maine and Mauritius, kids reflecting on what they've learned. Listen closely to the language they use.
Look. He looks like a shrimp, but I don't think he looks. Wait. Why is it staring you down?
I don't know.
It's called a nodder.
Why did it do that? That's actually scary.
Has poor vision.
Oh.
Oh.
We could have just trapped it the entire time.
They go so loud.
We could just.
How is that a cuttlefish?
Oh shoot! It's a cuttlefish.
That does not look like cuddly.
It comes from the ocean, of course. It isn't.
Okay, what are you doing? How did you do that? Oh, you can. Oh, we can just the entire time.
But I wouldn't want it in real life.
It's scary. It was crawling towards me.
Was it crawling towards you?
It actually like moved. Weird.
It's pretty cool to see it like in action, right? And then you could stop and flip it around.
Quinlan says he's hollow.
There's only a single specimen.
Hey, he has whiskers.
That last one was a giant isopod found at a whale fall at 1,500 meters. So let's see, where are we here? So the kids, you heard the kids talking about the creatures they're discovering. They're talking about the deep sea as if they've been there. They're describing the color of bioluminescent creatures, the sounds of hydrothermal vents, the feeling of exploring the unknown. For many students, this is their first encounter with real marine science. Connecting action to what happens in the ocean is where ocean literacy transforms into stewardship. I think you might have to do that.
Is it trying to?
Here we go. Explorer's now been recognized by the Ocean Decade for Sustainable Development, endorsed by the Blue Schools Network in the US, in Africa, in Europe. We've been honored, of course, with the Unity for Humanity Social Impact Prize this year. We won a Serious Play Gold Award in 2023, a Marcom Platinum Award for Communication in 2022. And we just learned yesterday that World Ocean Explorer was featured as a digital resource at the COP30 Brazil Virtual Ocean Pavilion. While awards and recognition are key to future funding, which in turn allows us to continue to allow Explorer free of charge to teachers, schools, and networks globally, it's the teachers that lie at the core of the platform's success. Every time we hear a teacher tell us how much they're enjoying the platform, sending us photos and videos of students exploring in a rural classroom or in a school in another country, we're seeing the ripple effects of this work. It's intensely gratifying, and these are the impacts we care about most, spreading access one classroom at a time.
Seeing how teachers and students have embraced World Ocean Explorer has reminded us that what this work is really about, connecting knowledge with experience through collaboration and creativity. Now let's look ahead at what's next for World Ocean Explorer and how we plan to keep it evolving as a living, expanding platform for global ocean literacy. Insights. Awareness. We've learned that advancing ocean literacy starts with visibility, reaching educators globally and showing that immersive, accessible ocean learning is possible. Awareness is about building recognition, demonstrating value, and helping teachers discover tools they didn't know existed. Without visibility, even the best resources never reach the classroom that needs them the most. Equity and accessibility. Equitable design means identifying barriers, technical, linguistic, financial, and resource-based, and building systems that remove them. Accessibility ensures that all students, regardless of device, ability, or learning style, can navigate and learn without obstacles. Together, equity and accessibility ensure that every learner can participate fully, not just those with the newest technology or the fewest challenges. Engagement. The more interactive and personally relevant we make the experience, the greater the student buy-in and curiosity. Engagement grows when students feel agency, exploring, investigating, and making decisions, turning passive content into active learning that sticks. And finally, funding and curriculum. Real success depends on finding funders and fitting seamlessly into classrooms, aligning with standards, budgets, and what teachers genuinely need. Sustainable growth comes from meeting educational requirements, easing teacher workloads, and securing the support that makes long-term development and maintenance possible. As World Ocean Explorer continues to grow, our focus is on expansion, both content and community. Content-wise, updating current modules, adding new modules. We'd like to have an ROV simulation soon. Gamification, adding badges and rewards for students in the game, and more data sets. Here are some new modules currently in development. This is a simulated submersible that promotes mission-based learning. Students can simulate real data collection, make observations, and record their own discoveries. The data can then be exported and brought back into the classroom and used for analysis with spreadsheet data, visualization, and report rating, essentially having their own expedition. We've also been testing a central Nexus hub, a starting point that will guide users to different modules as they develop over time. And as you can see, each one of those portal doors would bring you to another WebGL about a particular topic about the ocean. The goal is to create a connected platform where each new environment feels part of a larger living ocean system. Upcoming modules include, as we mentioned earlier, Science at Sea, which explores the history and methods of ocean research. Tropical marine ecosystems, which explores biodiversity and environmental dynamics in these warm water habitats. Maritime work, which examines people who work at the sea today and throughout history. And polar regions, which focuses on the importance of how the Arctic and Antarctic ocean systems help regulate climate conditions. The Nexus will link all these experiences together and reflect how the ocean connects us all. All these modules, as these modules roll out, they will include gamification elements, interactive assessments, and live data sets, further blending scientific accuracy with immersive engagement. To make the vision a reality, we're expanding cohorts and classrooms globally. Imagine a classroom in Maine and another in Mauritius, both exploring the same virtual ocean, collecting data, comparing results, and learning together as a global team. We're working to align our modules with next-generation science standards, Common Core, and international STEAM STEM standards so they integrate naturally into classroom teaching. We're also embedding more learning assessments directly into gameplay, making exploration and evaluation part of one seamless experience. Upcoming builds will feature multilingual support in English, French, Spanish, and Portuguese, along with new accessibility features like audio narration. That's where Ocean Explorer is headed, not just a tool, but a shared platform for collaboration, discovery, and global connection.
Thank you. So if there's one takeaway from our presentation today, we hope it's this. The ocean connects everything, from the air that we breathe to the water that we rely on, to the climate that controls our weather and contributes to our health. What began as a simple idea to make the ocean accessible has become a growing ecosystem of educators, scientists, developers, funders, and students, all working together to inspire the next generation of ocean stewards everywhere. It's a reminder that technology, when guided by purpose, has the power to inform, inspire, engage, and transform how we learn about our world. For us, Explorer isn't just a game or a program or a project. It's a movement towards inclusion, curiosity, and caring for the one ecosystem that connects all of us and everything. Explorer is meeting and exceeding our expectations, turning knowledge into empathy and empathy into action. Before we close, we want to thank the incredible partners who have made this journey possible, our small team at World Ocean Observatory, Visual Solutions Lab, the Schmidt Ocean Institute, the Daniel K. Thorne Foundation, the Seth Sprague Charitable and Educational Foundation, the Climate Change Institute, and Unity for Humanity Social Impact Prize. And of course, Unity Technologies and the global team for making this immersive educational tool possible. Each one has played a key and vital role in our success to date. And of course, the teachers and educators who are using and sharing World Ocean Explorer. Their enthusiasm, curiosity, creativity, and commitment are what keep the project growing. We're grateful to be a part of a community that believes in using technology not just as a tool to entertain, but to educate, enlighten, and to engage.
We hope today has shown you how powerful interactive technology can be when it's used to inspire understanding and promote stewardship. Any teacher out there, interested partners, potential funders, we'd love to meet you and hear from you, or someone you know who would benefit from World Explorer. Thank you.
Thank you.